We are used to think about stars as point sources in the sky. But are all of them point sources for real? Today we're going to speak about the astrophysical object of the month, March 2025, and this is going to be a favorite of mine, TW Hydrae. Welcome back to Boring Astronomy. I'm Alessandro, your astronomer next door.
Boring astronomy.
In case you're wondering, I'm Alessandro. I have been an astronomer for the past 20 plus years, and I'm here to share with you some of the things that I've learned along the way. So this month object is TW Hydrae. From the name, you already guess probably that this is a variable star. Objects whose names start with a couple of letters normally are variable stars, and this is no exception. Here I'm showing you the night sky over Sydney, Australia. This is for my friends who live in Sydney. You can see the moon, Mars, and you can see some famous constellations, the lion, the crab, the small dog, Orion, and you can see this very long snake. Australia snakes and dangerous animals. But this is not any snake, this is the sea snake or sea serpent, and is Hydrae. If we look for the object of this month, TW Hydrae is just there in the tail of the serpent, and you can basically identify it following Alpha and Beta Centauri, the Southern Cross, and then you sort of take a turn. It's a relatively faint star, so you actually need a small telescope or binocular to look for it. And you just start zooming in, and you end up with a point source. Did I lie to you? Didn't I say that this was more than just a point source? Let's go check on Simbad what we easily can know about this star. And this is what we know about this. We know that it's a T-Tauri star. We know its coordinate, 11 hours and minus 34 degrees. Minus 34 degrees, it tells us that it is best observed from the southern hemisphere. Especially if you're following my newsletter, you will have found out by now how to identify if a star is observable for you. We see that it's slightly off the plane of the Milky Way, and we see that it's a faint star for us humans, just with our eyes, but it's a relatively bright star by any standard of a relatively modern observatory. And we're coming back to this extrasolar planet in a second. If we look at the papers which speak about this star, we see 2,000 papers. Notice that ADS has an option which is to look for the object, if the object is mentioned inside the paper. So, because in some cases, and we're going to see one in a second, the object is not mentioned in the title. And basically the story and the excitement about TW Hydrae started in 1983. And from there on, it only got better. You can see how the number of papers about this object have exploded, especially after the 2000s. And the reason for this is because this is a T-Tauri star. What is a T-Tauri star? A T-Tauri star is a star which is still forming. It's a star which has already started its nuclear burning inside, but is still accreting material from the cloud from which it formed. So not only has the star per se, but it also has material around it. This makes it particularly interesting because, and you have seen some of the titles were referring about emission line stars. Stars normally don't have emission. The emission must come from something which is around the star. So if there's something around, there's something going on. If there's something going on, it's not just any star, like the sun. With all the due respect, buddy, you're very kind, you're very nice, but the sun is just an average one, right? So we have this star, which is actually slightly less massive than the sun, and is smaller, and it's accreting matter. This is a beautiful astrophysical laboratory, and especially a place where you can look for formation of planets, which is actually one of the reasons why this star became so exciting. Because if a star is small and is light, if there is a planet going around it, the effect of the planet is going to be stronger on a less massive star than on a more massive star. So this star was ideal to look for planets. There was actually a series of works. One discovered the planet, was actually a friend of mine. A friend of mine discovering that that planet was actually not a planet. Then there was another discovery on another planet, which was a little bit further away. So there's a planet, there's not a planet, lots of discussion, and then this paper here did some of my favorite all-time observations. So it took the Atacama Large Millimeter Submillimeter Array, ALMA, from Chile and observed it in radio wavelength. If you follow the newsletter, you probably already know the spatial resolution of a telescope goes like lambda over d, where lambda is the wavelength and d is the size of the telescope. In other words, your telescope is going to have a better resolution if you observe as small wavelengths, and your telescope is going to have a better resolution if you observe with a very, very big telescope. Now, building a very, very big telescope is very, very difficult, and observing at low wavelength is not too difficult, but it's very difficult from Earth. You can actually play a similar game, but in radio. So you can observe in radio wavelengths, which are long wavelengths, but you can build a very, very, very big telescope. And the trick here is that you don't need to build one big telescope, but you can build several small ones and make them work as if it was one. Eventually I'll make a video about this. But basically this is the principle that these people have been using. And let's go and let's check it out. This is the paper. The paper is very short because it's just a letter. A letter is communication, which is very, very important, and therefore you try to publish fast, but to be published fast it has to be short, so that it's more punchy. So, and as I was saying, not all papers cite the name of the object in the title, and this is the case of this one, right? The rings, the substructure, and a gap at 1 astronomical unit in the nearest protoplanetary disk. The paper only has 2 figures, which are these ones, and let's look at them. Basically, here we are looking at something which is the size of 2 arc seconds. 1 arc second, for us to understand, is normally the size of a star in a normal telescope. And here we are looking at something which is one portion of it. And actually, you can see this small circle here is the spatial resolution that they achieve. Quite remarkable, isn't it? And you can actually see all these structures. This is not an image per se. This is, as they say here, the synthesized image. Basically, they put together all the data that they receive from the radio telescopes, and they synthesize what is the most likely astronomical image that would produce the data that they record in the radio telescope. And this is it. And you can see all these rings. And you can see that there are some brighter rings and some darker rings. They interpret it as the formation of planets right in front of us. I'm sorry, I get excited about these things. Another thing that I get particularly excited about is that all these data are public. So if you don't believe this data, if you want, you can actually go and check it yourself. How to do it? Here we go. This is a classic of mine. One of the first things where I go when I want to see an object, and this is ESA Sky. You just search for TW Hydrae, and you can see that this is telling us that here we have observations from the Hubble Space Telescope, from ALMA, from the JWST, from Herschel Space Observatory, Suzaku, Spitzer, and we also have catalogs, and we also have spectra and light curves. Most of these you can actually access from the archive of the Space Telescope. So let's go and check it. So this is the website of the archive of the Space Telescope. You can see you can access Hubble Web Tests. You will be able to access Roman, as well as many more. So let's go to the Science Portal and let's search for TW Hydrae. And you can see that there's 3,200 observations from several missions. You can look for images, spectra, time series, and I just want to show you this because I think it's fantastic. Okay. And you can actually see that you can look at the light curve detected by TESS by yourself. I didn't enter with any particularly credential of professional astronomer, whatever. And you can actually see how the variability of the object, and you can analyze it yourself. And you can even download the data and analyze them on your computer. A lot of the debate of the planet, no planet, was done with data from the European Southern Observatory. So it is quite logical to go to the archive of the European Southern Observatory and check what data they have. So let's go to the Science Portal, and you can see that it has data cubes, has spectra, has images, and it has catalogs. Let's only focus on cubes and spectra, and you can see that it has a lot of cubes from ALMA indeed. Alright, so let's check this out, for example. And you can go and look at the spectrum, look at the continuum, look at the maximum of the cube. You can analyze it. You can check images. You can look at spectra, and this is just for our entertainment. This is an image taken with sphere. The person who asked this observation is actually a friend of mine. Or you can look at spectra, and this is an example of how a spectrum of this star looks like. This is a little bit zoomed in, so let's zoom it out. You can see this is clearly H alpha, this is H beta, H gamma, and you can analyze it yourself. You can go and analyze all these lines, you can check the shapes, you can check what is interesting and what is not interesting on this spectrum. So I hope you got excited about TW Hydrae. It's a relatively easy object. If you have a telescope, you are probably going to be able to observe it easily. You can probably even observe it with a binocular. And you can participate in campaigns or provide the American Association of Variable Stars Observers with super valuable data about the variability of this object. So I hope you enjoyed this. I hope you learned something about stars and emission line objects. If you're interested, you can subscribe to my newsletter. The link is below. And obviously, like the video, subscribe the channel, and I hope to see you next time. For the meantime, stay bored. Ciao.